Hello students and YouTube learners. This is Dr. Satish Singhal, PhD, Professor of Computer Science at El Camino College, Torrance, California. Today I just want to talk about a special topic which is called aggregate and non-aggregate operations on structs and arrays. It's an important topic and this video would be quite short. So let's get started. What is an aggregate operation? Aggregate operations mean that what is assemblage of operations that we can perform on a data type. So data type is like int, double, etc. And then you have array, which is not a data type but a structure of data structure. And struct is a user-defined data type. So what is the assemblage of operations that we can perform on a data type? So for example, for atomic data types such as int and double, following assemblage of operations are available. You can input int and double using cin arrow arrow or fin arrow arrow. Fin is the stream object. Or you can output them using cout arrow arrow or fout arrow arrow, where fout is the offstream object. On int and double, you can also perform arithmetical operations such as plus, minus, multiply, divide. Um, Modulus is only available for int, not for double. Or you can use comparison operator to compare them, just like greater than, less than, greater than equal, less than equal, equal for content, and not equal. Or you can use assignment operators such as equal, so that if you have a variable here, then value from this side will be stored into this one. However, attempting most of these aggregate operations on arrays or struct will be a compile error. And that means that most of these aggregate operations are not available on either on struct or arrays. So that's a very important thing to understand, that aggregate operations you are used to doing on a struct and array on int and double are not available for struct and arrays, but there are just one exception each, for one for struct and one for arrays, that is available. Okay, so we're going to talk about that. So no aggregate operations are available either for arrays or struct, except two exceptions. What are the carved out exceptions? For struct, the assignment operator is available, and that means structs are assignable, and we'll demo that in our compiler in a minute. For character arrays, when array cells are filled sequentially with character, and last character is a null character or null terminator. Null terminator is simply apostrophe, / and 0 and / closed. That can be outputted using cout, etc. So that's an aggregate operation on the array. Only one aggregate operation available on the array. So we just discussed these two exceptions to otherwise the reality that there are no aggregate operations for arrays and structs, and we're going to demo that in our compiler Xcode. So let's just go to our compiler Xcode here. So let's just see first this code. So I have a struct called student here, and just has two members, name and age. We can put more, but it's not necessary to demo that assignment operator works for the structs. And I have print function to print a student object passed by const reference to save on memory. And let's look at the code for the print function. So code for print function is very simple. We print the name, and we, as you know by now, we access struct members by dot operation. So st dot name and we print age, st dot age. So whatever name is stored in the st, that will get printed, and whatever age is stored that will get printed. Okay, so we see print function now, so we can collapse that. So now what I do here is I'm creating two objects of student type, S1 and S2. So I set the name field of S1 to John Adams. So as you know from previous videos that you can have write access to struct members after you select the member by dot operation. And so I selected the name member here, and I set that to John Adams, and I select the age member of S1, and I set that to 65. And I think if I see here, okay, flat, this should show me both members, but somehow it's not. Okay. Let's see. Functions. Okay. So that's, I was thinking that it will show me both members, but it doesn't. So it doesn't matter. We see them here. Okay. Then I take the S2 object and the name field is set to Lisa Apples and age field is set to 23. Okay. So you can draw your own box here like S1, and if name field you can put John Adams and age field to 65, and same thing with the Lisa Apples, name field to Lisa Apples, age field to 23, and then I print them separately. Okay, so let's print them up. Let's discuss the code up to here, and let me just comment that out. Okay, so there's not much surprise here. I'll print function will print John Adams and 65, and then Lisa Apples and age 23. Let's just go ahead and do that. And yeah, no surprises. Printing student S1. So print function prints the name John Adams and age 65 years for student S1, which we set here, those two. And then I'm printing S2, sending print S2, and no surprise there. Lisa Apples and 23 years, these values are printed right here. Okay. So big interesting things happen when we set S2 Lisa Apples to John Adams. So let's see what happens then. So I'm going to uncomment this code here. So I do this setting here, S2 equal to S1. So what is being done here is you're telling computer that S2, which is Lisa Apples, take John Adams from here and copy and paste as if you copied and pasted here, and take age 65 as if you copied and pasted here. Okay, that means both S1 and S2 should have same content. That is what's called structs are assignable. So assignment operator works for struct, just like if you took a variable x, you put 10 in there, another variable y, you put 20 there, and then you say y equal to x, then both will contain content of x, which was 10. So same thing here. So that's proving structs are assignable, and will get proven when we print S1 and S2. They should have both John Adams and 65. Okay, so let's see that now. Okay, this was S1, John Adams, 65 years. This was S2, Lisa Apples, 23 years. Now we did in the code S2 equal to S1, which is right here, line 26. After line 26, then we both print S1 and S2 both. S1, S2, and now they're both containing John Adams. See, that's the meaning of that structs are assignable. Means once you put a struct on left side, equal structs another struct on the right side, both will have the same content then. That's how structs are assignable. So only aggregate operation that works for struct is that they're assignable. Assignment operator will copy member by member from struct instance on the right to the member by member into the struct on the left. That's the meaning of aggregate operation of assignment. Okay, now let's show you for the array of character, and for that I'm just going to comment out all this and comment in this one. So here I have a array of characters, friend's name, and I don't need to put a length here if I have hard-coded values on the right. It's not necessary. And I have character J, character O, character H, character N, John, and the last one is null terminator, /0, and even though there are two characters there, this behaves like one character. Okay, and then I'm doing cout friend's name ENDL. And notice that you couldn't do that for any, if you did that for any other array, int, double, float, or string array, you will get a compile error because aggregate operation of outputting an array is not allowed. You know that very well by now. So, but let's see in this case what happens. So, we compile it, and lo and behold, it prints John. See, John. So what that means is that only exception allowed for aggregate operation on an array is just for the character array, as long as every element of the array is populated with the last character being null terminator. If that's not there, no other, if I don't give it a value, then this will be compile error, of course. I can give a blank if I want. That's not a problem. But there should be something there, some character. And it should be terminating with the null character. Under those conditions, the aggregate operation of outputting that character array is allowed. That's the only aggregate operation that is allowed on the array. And then you can read my chapter 10 on arrays, which gives more example of what is not allowed actually. It gives this example, and it gives example of what aggregate operations are not allowed, and if you wanted to do something similar to an aggregate operation, what do you have to do, like run a for loop or whatever. And we can already see that if I wanted to print a struct, I couldn't do cout st, rather I had to print each member separately. Okay, so that's it. There's not too much more in this video, and that's the end of this video. So thank you so much. And it takes me a while to shut down some of these things. Okay.